Hello everyone! Today we'll be going over the construction and implementation of the solution of problem 151 in my book, Learning Isn't Linear, into GeoGebra 3D Calculator. Okay, let's read the problem statement. Suppose you have a box of edge length 1 with non-congruent balls packed tightly inside as shown in figure 2.16. The center of one ball is at the center of the cube and it touches the other 8 balls. Each of the other 8 balls touches 3 sides of the box. Find the radius of the balls. In this video, we won't go over the mathematics of finding the radius of each ball, as the solution to that can be found in my book, Learning Isn't Linear. But what we will go over is the construction and implementation of this geometric construction into GeoGebra 3D Calculator. Okay, let's get started. So we want to make a cube with side length 1. So we want to go to Tools, and then click on the cube icon. And we want to make a cube that's centered at the origin, but above the XY plane. Whoops, that's not what we wanted. Okay, that works now. We can see that when clicking the 2 points going in the clockwise direction or counterclockwise direction, it makes a difference in the location of the cube. Of course, we can change the color and the opacity of the cube. Alright, so we have our cube, and we know the radius of each sphere. So now all we need to do is find the coordinates of the center of each sphere in order to pack them into the cube in accordance with the configuration in the problem statement. Okay, so in order to make this easier, we're going to look at a projection into the XY plane. So this is going to be an overview of the cube, and we're going to go work from here in order to find the coordinates. All right, so now we're going to be looking at the projection of the cube into the XY plane, or you can think of it as it's a top view of the cube. All right, so now since the cube has a side length of 1, the distance from here to here will be 1/2, and distance from here to here will also be 1/2. So here we're working in the quadrant where both x and y are negative. All right, so let's draw a circle with the center. So this is the sphere with its center, and we want to know what the center is. Now, you might be thinking, is the center just -1/4, -1/4, half of this way and half of this way? Well, pause the video to try to implement that and see if that works. All right, congratulations. If you said that the center is not -1/4, -1/4, you are correct because the radius is not 1/2. All right, so let's do this construction here. We have the radius from here to here. Since the circle is tangent to this line, it's perpendicular. So we have a square here. And then what's this distance here? Well, this distance here is just going to be 1/2 minus r. And since it's a distance for now, we'll just put in absolute values. Now, however, since we're working in the third quadrant where both x and y are less than 0, we want to look for the coordinates of this point, remember. So we're actually going to have r minus 1/2. Okay, so the center here is going to be r minus 1/2, r minus 1/2, because it's symmetric, as x and y are both less than 0. All right, and then looking at all the other spheres, we see that it's symmetric in the positive quadrant, where x and y are both positive. We'll have 1/2 minus r for the x component, and 1/2 minus r for the y component. And similarly, for the other 2 quadrants here, we get the coordinates of the center. All right, so we have the x and y components of the centers of the spheres, and then all that's left is to find the z components of the centers. All right, so now we know we are in the xy plane, but we want to find the z component of the centers of the spheres. Okay, so here we have the radius of the sphere. Here's the center, and we're looking at the bottom spheres here. So we have the radius. And then, so it just quite simply, the z component will just be r. All right, so now what if we want to find the z component of the centers of the spheres for the ones that are on top here? So how can we do that? Pause the video and see if you have an idea. All right, so what can we do? Let's just let's look at the radius. So we have the next radius of the sphere, and then we have this little gap between the 2 spheres here. Okay, so we have this little gap here. We're going to call it beta, and then we have the radius again, and then we have the radius again. So how do we put this into an algebraic equation now? So we want to try to get an algebraic equation from this information here. So we know that the side length of the cube is 1, so that means that 4r plus beta equals 1. Okay, so we have one algebraic equation. And what else do we know? Well, we also know that the z component of the center is going to be 3r plus beta. Okay, so the z component is going to be 3r plus beta. And now we can just solve for beta here and plug it into the second equation. And then we'll get z equals 1 minus r. So the center for the spheres on top will have z component 1 minus r. Okay, and what about the yellow sphere? Well, the yellow sphere is right in the middle, right in the center of the cube. So its x and y components will be 0 for the center. And then the z component, well, the z component will just be z equals 1/2. So this is the equation of the yellow sphere in the middle. All right, so let me let you guys look at the full line of code here. So these are just the points for the cube that I made. Okay, and then here is the equation of the yellow sphere. All right, and then these equations here are the equation of the spheres for each of the red spheres. So you'll notice here that I have 1/2 minus b plus r over radical 2. You'll have to look in the book, Learning Isn't Linear, to know what b is. But from the diagram that we had, you can actually see that it actually r is equal to b plus r over radical 2. So you can actually replace this expression b plus r over radical 2 with just r. Okay, and then all the sphere equations are very similar. We want to learn how to make a line segment in GeoGebra 3D calculator using 2 points, and we'll see how this will come in handy in just a minute. So I'm just typing in the coordinates of 2 points, A and B, with X, Y, and Z slots. Alright, so just start typing in the word segment, and then 2 options will pop up. Pick the first one with 2 points, and then just plug in A and B into the slots, and then it'll graph the straight line in the XYZ space, and it'll actually also give you the length of that line. All right, so now we want to go over how we can make this diagram here. So this diagram is actually a picture in the book, and it's how we can figure out the radius of the cube. But I want to show you how to construct this in GeoGebra 3D calculator. All right, so we learned how to make a line segment in GeoGebra 3D calculator using the segment function. So what we want to do is now we want to use that in order to make this line segment here, this line segment, this line segment, all these line segments, but in particular this green diagonal line segment and these 2 little red line segments. So that will be done by finding this point here, this point here. So essentially we just need to compute all these points here, and then we can construct the line segments. All right, so now what we're looking at is an overhead shot of the cube. This is along the main diagonal, so this is half a diagonal. So we're going to just name this red line segment B, okay? And since this is half of the diagonal, this is going to have length radical 2 over 2. So we want to construct this line segment B in GeoGebra 3D calculator. In order to do that, we'll need to find the coordinates of this point here and the coordinates of this point here. All right, so we're going to have a square here, okay? So we're just basically projecting this diagonal onto the x and y axes. So what's going to be the length of this blue diagonal here? Well, it's just going to be radical 2 over 2 minus b, which is what we have here, okay? Now we have to find the length of this side and length of this side. Well, these two are congruent, so they're equal. So what do we do? Well, this is just a 45, 45, 90-degree triangle. So all we need to do is divide by radical 2. So the length of this x slot, or this x component, is going to be radical 2 over 2 minus b, or radical 2, and the y component will also be that. Okay, and then what's the coordinates of this point here? Well, it's simply just 1/2, 1/2. So we have found the coordinates of both these points, and therefore we can plug it into the line segment function in GeoGebra. All right, so there's a couple different ways we can solve this problem that you'll find in my book, Learning Isn't Linear. One such way is to essentially put a skewer through the main diagonal of the cube, so it goes through 3 of the other spheres, 2 of the red spheres and the 1 yellow sphere. So I've constructed that line segment here. It's the green line segment. So you see I've put a skewer along the main diagonal through these 3 spheres here, and this will help us solve the problem. Okay, so there's actually a second way of solving the problem. We can take a plane and slice right through the cube, okay? So I've constructed that plane right here. So how do I construct this plane? Well, there's the plane function. So what do you need to construct a straight line? You need 2 non-collinear points. To construct a plane in XYZ space, you need 3 non-collinear points. So these are the 3 non-collinear points I have here for the plane function, okay? And you see those points are just the corners of the cube here, which are not too hard to find, 1/2, 1/2, 0, and so on. Okay, so I have this nice plane cut through the cube. Now, how can this help us? Okay, so the line segment from here is pretty easy to find. You just need to find the coordinates of this point and that point, which are here and here. So we have these 2 line segments here. And to find the leg segment from here to here, again, we just need the coordinates of these 2 points, which is this here, this segment. And then to find the line segment here, we need the coordinates of these 2 points, which is here, which is this line segment. All right, so we define k to be our value, radical 2 over 2 minus b over radical 2. Okay, so we have our point m is equal to k0, which is here. And then we have our point n, which is here, symmetrically, minus k0. And then we have our point O, which is here. So now we have the line segment from here to here. Then we also have P, which is here. So we have our 2 line segments. Okay, so now we have everything we need to construct the red line segments. So we know this point N here and this point here. So we have this segment here, this red segment. And then we know this point here. We know this point here and this point here. So now we have this line segment. And then let me just take off some of this other stuff so you can see the full picture that will help you with solving the problem in the book. Okay, there you have it. And then actually let me take away these points here. Okay, and then this is almost the exact same picture in the book that we've constructed in GeoGebra 3D Calculator. I think this is going to be very helpful for you solving the problem and for teachers presenting this problem in the classroom. Okay, so once again, let me just let you guys see the full line of code. If you enjoyed watching this video, hit the like and subscribe button now. Also, check out the links in the description. And remember, prioritize long-term learning over short-term test taking.